So concentration and molarity deal with the concentration triangle. However, like we saw in our first lesson, we can also have multiple triangles pop in for the same question. So I've taken two questions from our worksheet. I've actually done number 2 first because it's simpler, and then number 1. So number 2 asks how many moles, so we're trying to find N, of copper nitrate are present in 25 milliliters of a set molarity of a solution. So moles per liter will always be our concentration, and milliliters is a type of volume. However, when we're doing math, we need to make sure our volume is always in liters. So if something's given to you in milliliters, you want to divide by 1,000, or take that decimal and move it 3 times over. So I've already done that. 25 milliliters is going to be equal to 0.025 liters. So we've got our V value, we've got our C value. They're side by side in the triangle, so if we multiply them, we'll be able to find the number of moles. So that's what we have here in the orange. We have our concentration multiplied by our volume in liters, and we come out to the number of moles. So it's likely this is what it's going to say in your calculator. What that means if we put it into scientific notation is that if we take that decimal and move it over until we're 1 past an actual digit, that 5, we've moved it 1, 2, 3, 4 times over. So that's where that 4 comes from. And because we've taken a small number and made it larger, that's where that negative comes from. So it's the opposite of what we saw with Avogadro's number. It didn't have a negative, right? Because it was a really large number. So large numbers that go into scientific notation don't have a minus. Small numbers that go into scientific notation do have a minus. So it's up to you. If you want to keep it like this with a bunch of zeros, that's a fine answer. If your calculator comes out this way, or if you want to convert it, that's just, these are the exact same quantities. So that's if we just use one triangle. The first question, though, has us going between two triangles. So we want to calculate the molarity. So we want to find out the concentration of a solution in which we have 2.34 grams, which is our mass, of magnesium chloride present in 2.00 liters of solution. So we have a volume. So we have volume. We want to find moles per liter. So we have those two values. However, we don't have moles yet. We can't just use that one triangle. What we do have, though, is mass, and we can always find molar mass. So we can use our mass, moles, molar mass triangle in order to find moles first, and then use the concentration triangle. So we've got magnesium chloride. We'll have to find its molar mass first. So step 1, we've gone to the periodic table and found the molar mass of MgCl2. Step 2 is using the molar mass triangle with the mass that was given to us and the molar mass we just found in order to find the number of moles. And then we've taken that number and put it into the concentration triangle so that we have the number of moles we just found divided by the number of liters that was given to us in the question to find 0.0123 moles per liter in the end.